Humanoid robots are having their moment. Every day, a new video is coming out, a new demo. They are chopping vegetables, they're folding laundry, they're doing kung fu, they're playing sports, they're moving boxes, they're delivering boxes. Each day, a new promise that they're ready for the real world. But let's be honest, you and I, we are not ready to let them inside our homes, inside our lives just yet. And here's a question that we should be asking us. Are we designing our systems to be safe or to be impressive and more human-like? We love to reference Asimov's 3 laws of robotics, but those laws don't exist in code. What does exist are design decisions, training models, policies, controllers, autonomy, manufacturing shortcuts being taken, market pushing competition, and trade-off decisions being made under pressure. So when safety fails, it's not philosophy, it's engineering decisions, it's business decisions. Today, we're lucky to have my new guest, Amir Sharif. He's no stranger to safety. He has founded companies within cybersecurity that were acquired by giants like Cisco and Palo Alto Network. He's a veteran in the Silicon Valley. Now, he's a chief operating officer of 3 laws. It's a company that's defining safety layer between autonomy and controllers for physical AI, for robotics, for autonomous systems. And if we're serious about a world that's going to be filled with robots, this is the exact conversation that we should be having. I'm excited to get into the present state of robotics from his eyes, what founders can learn from Silicon Valley's mistakes in past, and what future holds for us. He's in the right rooms, having the right conversations with the right companies, and we're going to get the insider's look today. My name is Ali Afzal, and this is Robot Builders Club. Let's dive in. All right, Mr. Amir, pleasure to have you. So nice to finally get 3 laws on the podcast. I'll jump straight into it. When I met you, I saw 3 laws. It reminded me of the Isaac Asimov's laws of robotics. The robot will not harm a human. Robot must obey a human's instructions as long as it doesn't interfere with the first law. And then third, robot must protect its own existence. So you're in the business of making sure the autonomous systems and robotics are made safe, which is such a need right now with such growth happening in robotics. Let's kick it off with how were you inspired to come up with the name and get the core product going for this company? Welcome to the show.
Well, thank you, Ali. Thank you for having me. Gladly. Let me tell you a little bit about the background of 3 laws and where the name comes up from and how it has inspired the company. So you're correct that 3 laws is inspired by Isaac Asimov, which if you sum up the 3 laws, it says basically robots should be in service of people. The 3 technical co-founders, Aaron Ames, Andrew Singletary, and Thomas Scurrier, have been working together for about 10 years. I joined them shortly after they formed the company as a CEO, but they together have created the mathematical framework for a universal safety layer for any moving object. So as long as you can electronically control it, and as long as there is a kinematic model that describes the object, then you can have a safety layer that effectively governs the behavior of the system that you're on. So as such, think of this as a system design challenge for us to make sure that safety is uniformly applied and less as science fiction, as the name Asimov suggests. Basically, we want to constrain the system in real time according to certain policies, make sure that you have fail-safe behaviors, make sure that the robot always stays within the boundaries that protect people and other equipment.
Geofencing.
So it could be geofencing, it could be stability, it could be not overheating, it could be not overexerting torque, for example. And that becomes more critical when you have less stable systems like bipeds, let's say humanoids. They tend to be heavier. And if they fall, if there's a fatal flaw, they will fall. And you don't want them to fall on people. So you have to have a set of fail-safe behaviors that constrains their movements so that in case there's a catastrophic failure, they don't hurt your grandma.
Right. And the product that you're deploying, I looked into it, the supervisor that is sitting between autonomy layer for a robot and the control, the movement piece, right?
The controller, that's correct. Yeah.
Yeah. So why, if I'm building a robot, why wouldn't I be already considering that piece? Why is there a need for something like this? Are robot manufacturers and companies, they're not considering this component?
There are two existing schools of thought. One existing school of thought is based on kind of traditional older robotic frameworks, which says that the robot is going to be constrained by physical barriers like fences and so forth.
In a industrial setting or warehouse setting, where it is already, lanes are already set, right? Like,
Correct.
yeah.
Correct. Lanes could be set, but now with autonomy, lanes could not be set. But the whole idea is that the system is generally inherently stable because it's on wheels or it's latched down and it doesn't move around, but you're going to keep it away from people. And as a last resort, you have a emergency stop button. You hit the red button and it stops, and that's good enough. So that's one school of thought. But notice the constraint that I had to put in there. There's a lot of stability. There are a lot of barriers. There's a second school of thought, which is now we have robots roaming and free autonomously. And as long as the autonomy layer is good enough, then safety is built in. So by becoming multiple nines reliable, the system will then behave in a safe manner. That may be statistically true, but it's not guaranteed to be true.
Yeah. So like in self-driving, you're talking, or a humanoid suddenly failing unpredictably, falling over, you need to respond in milliseconds, and failure is guaranteed. In the real world, you want to have it fail safely.
Correct. Yeah. So, the autonomy, if I can sum up the autonomy approach to safety, is practice makes perfect. That if I learn enough, I'll just become safer and safer. And there are two different standards. In the factory, we have a zero failure policy that we don't want any accidents. In the real world with cars, we tolerate deaths and accidents. So that approach may work well if the regulatory system says, okay, a few accidents here and there are okay, and insurance policies are going to cover for that. Regulatorily, it does not work inside the factory because you have to have a zero failure scenario. And if you are retooling factories with autonomous systems, which is going to be advantageous, they're faster, more nimble, they create better scale, you want to have a safety policy that gives you that guarantee and gives you the ability to meet regulatory requirements, yet have the smarts of an autonomous system. This is not to say that 3 laws is not applicable to autonomous cars. It just says that it can bridge the gap between full autonomy, take advantage of that, basically let your autonomy layer run loose, yet have a layer of deterministic behavior between the autonomy layer and the controller so that the system always adheres to policies and makes sure that the system's stable and safe.
Yeah. So, no, thanks for explaining that. So going back to my original question, why aren't the Teslas of the world and a humanoid, whether that's Figure or any of these robotic companies that are coming up, why is that the safety layer, something like your product, why is that a need? Why aren't they considering, or they are considering it, but that's just not their core focus, and they just haven't focused on that in product development cycle? It's too early. Just trying to understand that.
So let's bifurcate Tesla and Figure. You put two leading companies that are
yeah.
working. So Tesla does have fail-safe systems. Like I have a Tesla, and if I'm not paying attention, emergency braking does happen.
Right.
First, the car screams at me, then it stops.
It
has done so because I've been distracted before. But even when it comes to full autonomous driving, there are emergency braking systems that are independent of the system. So Tesla has embodied a version of this. What they're taking advantage of is that the car is on 4 wheels and you can't stop in the middle of the highway. Whereas, with a humanoid, that's hard to stop. Now let's go to Figure, and let's not pick on Figure specifically, but there's kind of a rush to humanoids.
Yeah.
And that's makes me scratch my head. If I think about it, like why has it captured investors' imaginations? Because I see that, there's something that looks like me. There's something that has an LLM. I can put them together. Science fiction is here. Like now humanoids will do the world. And then there's a bit of lazy thinking that's like the world's built for people. Therefore, if I have robots that look like me, then it can do a lot of work for me. The counter argument that I would make is that even though, in a human form, I can do certain things pretty well, my form factor isn't particularly well suited or optimized for any of the tasks that I do. Like if I'm a vacuum cleaner or a lawnmower, probably a disc-shaped thing is the best form. That's low on the ground and
task-specific.
Task-specific robots, right? So Building a universal robot misses a lot of optimization that you can do with task-specific robots. So I think the humanoid craze at some point will fade away. But in the rush to get humanoids out, safety has become kind of a last mile
Mm,
thought pattern, which makes it, everybody wants to get high performance robots out. They can do dancing and backflips. But how many videos have you seen where,
Unitary, all those videos are circulating, right? Of
right? Yeah.
robots doing all of these acrobatics. Yeah.
And they have some safety built in, but they're not. Safety wasn't designed with the concept. It's an afterthought
mm,
that comes after the performance is handled. In our view, high performance can become, if safety is done correctly, you actually have a higher performance system that lowers liability.
Got it. Yeah. So I guess I was leading with a question that didn't make sense. It's your product is more for companies that are focusing on product development and they're early in that stage where safety is not yet a concern. They're focusing on stability. Focusing on getting the robot to do the task that it's being designed for. And you're enabling that safety layer. Those three laws, you're inputting that for the system that is being deployed. Is that,
That's correct.
yeah?
Think about, let's use cars as an example. When the car industry first started in the US, everything was vertically integrated. The same
mhm.
company would make the engine and the car body and the windshield and would assemble them all together and would put it out to the public.
Yeah.
As the industry matured, it became more componentized. So there are these horizontal players that do wheels, then tires, and then do braking systems and so forth. And then they may make those systems per specs of manufacturers, but the manufacturers come in, the OEMs come in, and they do a vertical play, and they say, okay, I want these tires, this transmission system, this kind of catalytic converter, this kind of drive system, and then I'm going to put a car out. I may do some assembly and modification myself. I may make some custom parts myself, but the industry is such that for me to get a particular model of car, that car company has sourced from a lot of different suppliers.
Right.
As the robotics company matures, you can anticipate the same industrial behavior where actuators come from somebody, the controllers come from somebody else, sensors will come from various people, and safety systems will come from other people. We are creating a universal system that's applicable to the entire industry and can be horizontally applied regardless of the form factor.
Got it. Yeah, no, that makes total sense. You're trying to solve something that's a hard technical problem, and safety is becoming more and more important, and it's going to be increasingly important as we deploy different types of robots in commercial and more settings that are outside of those industrial settings where things are controlled, right? As it gets inside your home, then we cannot have any failure rates. So do you think the problem that you're solving for, are you getting the sense from the market that they understand that this is a problem they need to solve? And are they admitting that this needs solving in this moment in time?
Let's categorize the market in three chunks. One is legacy, one is emerging, one is experienced. So if you're a legacy player, you're used to solving things with old school and, a stick e-stop system is going to be good enough for you. That system is going to be less autonomous, less performant, but it has some level of acceptance. And if you're happy with the cash flows that are coming in, you're not going to really look towards innovation. Then, there are the innovators who are trying to show off backflips and dancing.
Yeah.
And for them, safety, they're not really thinking about productizing the system yet. They're racing to show these proofs of concept to capture people's imagination and to direct investment funds into their companies so they can continue growing and innovating. Then the last category is experienced people. People who have done robotics for a while have broken their picks on this hard problem. And they realize that, yes, this is a problem that I need to solve and I can't do it very well myself. Case in point is U.S. Air Force that has had a lot of experience with robotics. And now they have a program called Vista. The part of the purpose of the program is to have AI pilots flying around F-16s. So having had that experience to realize how important safety is. So we got incorporated into the Vista program and flown on jets. So that's a case point of when you know how hard the problem is, then this approach becomes a meaningful one. Until then, really, the companies haven't matured to understand that they need this problem, either because they're happy with existing solutions and they're happy with the revenue streams, or they're racing forward on design alone without safety. And they're saying that, yeah, safety is something I can throw after the fact.
That makes sense. You have a background in cybersecurity, right? So in that world, you start with the assumption that you've been breached, and you build systems around that to make sure that safety is prioritized. What's an equivalent uncomfortable truth in robotics?
So, with cybersecurity, until the cloud became a thing, at first there were like these virus wars and everything. The spreading of these viruses were fairly limited. That's because things weren't networked very much. So nothing was built for assume failure, assume adversity, and that how you build software. Software, once, cloud computing and internet became viable and started spreading, and these threats started spreading rapidly. Then at that point, people kind of woke up and had the oh shit moment that, that my software isn't safe, my corporate
Yeah.
assets can be compromised and so forth. Robotics is going through analogous phases, it's not one-to-one in the sense that if you're an innovator, you aren't assuming that it can be an adversarial world. Adversarial in two aspects. One is that, other cars could hit me, other devices could hit me. You can have kind of a doomsday scenario where a system gets hacked because of cybersecurity and then safety is violated and so forth. That's less probable, but you have to assume that it's an adversarial world, and you want to design so that certain failures and certain danger situations cannot happen with your system. For instance, if a pilot dies behind a 777 airliner, that airplane is designed to just stabilize itself and cruise until things can happen. It's not a dynamic system where it wants to roll and pitch and yaw. So that's an example of safety built into the design. And we haven't thought through those cases in robotics yet, just as we hadn't thought through software safety and cybersecurity until, let's say, pretty seriously until around, let's say, 2007, 2008.
Yeah, it's a function of time, right? The industry is fairly new outside of the industrial applications. Is that the reason why we're not there yet?
The way people engineer products is they wait for the problem to occur
Makes sense, yeah.
at high rates, then they go address it. And if it's kind of a thankless job that if you build it in and it works well, people kind of expect it.
Mm, yeah.
However, if you're clairvoyant and you build a high reliable, high performance system ahead of time,
Mhm.
you position yourself for market leadership and taking share from other people.
Yeah. And speaking of issues within robotics and potential failures waiting to happen, what do you think is going to be the first robot disaster headline that hits our news feed, which will cause people to start paying attention? Do you think that's what will it be, and do you think it's inevitable that we're going to start seeing these headlines coming in?
It's inevitable. Most of it, I think, is BS. It's a fact that automated cars, or autonomous cars rather, are safer than people. Statistically, they're much safer. Yet when a Waymo or a Zoox or something has an unfortunate event, and an
Yeah.
event could be something like, oh, it blocked an intersection because it got confused, then it makes all sorts of headlines. We don't talk about, the 1,000 other analogous cases that happened on the
Yeah.
same day where a human blocked a intersection.
Yeah, bad driving from a human goes unnoticed. We give it a pass that, that person's a bad driver, or they had a bad day, or lack of judgment. But a single incident with an autonomous car gets up in the headlines that, look, it's a failure.
It's a failure, and it's clickbait because it's not a real problem, but it's titillating and tantalizing,
Mhm.
and people will read your article, and it feeds into this narrative that we have that, gosh, we could be in a world where machines will take over and we no longer have control. It's
Yeah.
an innate fear that we have. Now, those failures will happen, those headlines will come, whatever. The largest type of failure that's likely to happen is a that's real, is a cascading failure. So let's say you build a lights out factory where robots are orchestrating, and you haven't thought through the failure scenarios well enough. One small failure in one part of the factory will lead to the entire shutdown of the entire factory. And that could be a critical factory providing, let's say, key components for something that people use frequently, let's say cars. All of a
Mhm.
sudden, that manufacturer can't ship that car. That type of car becomes unavailable for 3 months because of a small failure that cascaded through the entire factory and created multiple failures across the board. So we're unlikely to see big disasters. We're
Mm,
across the economy. We're not likely to see the T1 Terminator
yeah.
scenarios. We're likely to see a few cascading failures where some companies get hurt financially because of cascading failures.
Yeah, and you bring up an interesting point that some industries are already well equipped just from regulatory standards that exist. Like defense, you had mentioned, is already thinks very deeply through different failure modes, and in their product development, it's ingrained. Automotive is the same way. Medtech, where I am, failure is not an option, right? I'm at Johnson Surgical Robotics, and we have a longer product development cycle because those regulatory concerns are absolute must. On the consumer side of things, whether it's Unitary and a US equivalent of a Unitary, whether it's a humanoid or a task specific robot, the pressure of getting a product out as quickly as possible will result in these failures. And that's where your services, your company, Three Laws, I think becomes paramount. It creates an opportunity for you guys to come in. Like I was thinking of 1X that they launched a subscription model for a robot, even though the utility wasn't quite there, right? And something like that where people are jumping on because of the hype, they bring it into the home. I'm not super familiar with the whole system that 1X has deployed, but not picking on 1X in particular, but having something in the house where safety has not been considered at that deep level as a regulatory product is a recipe for disaster, right?
Right. But the other side, I would caution that sometimes regulation and safety standards are built to create lock-in for certain companies. Yeah, there are regulatory moats that companies create in order to keep themselves in business and keep competitors out. So having regulation is important, but it should be sensible, and it shouldn't be designed to protect anybody's turf. It should be designed to protect the consumer and people.
Mm-hmm. Yeah,
So not
absolutely.
all
Right amount of regulation,
exactly.
which is tough to figure out. Right now, I think would you say we're in the on the left side of it, meaning there's no regulation. There's some standards with the ISO standards, and I'm forgetting ANSI.
And
Yeah, so there's some of that, but maybe a disaster happens, we'll quickly move to the right side. What are your thoughts?
so for existing robotic systems like manipulators, AMRs, there are a decent set of regulations. I would say, you know, it's 90% good, 10% overkill. And if you attend these committees, you can see that there are various representatives of companies who are pushing particular agendas. The same thing happens for, IEEE, where they decide, what, or the Internet Task Force, where people go in. But in every Internet Task Force, at least it used to be, that Cisco Systems would go and manipulate the rules so that
Yeah,
Cisco would benefit.
yeah.
It's overall it's good that people know what the rules are, but there is some overregulation for existing systems. For newer systems, there aren't enough standards, and they're emerging, and people are trying to understand what those are. Like the first question is, how do we use humanoids? The first question, for me, the zero question is, do we even need humanoids? But then a lot of people are asking, how do we use humanoids? What are their use cases? Therefore, what are the right set of rules to govern the behavior?
Yeah. So you think it's safety right now is and will be a revenue driver or just a tax?
Yeah, most people, the way they think about safety right now, it's a tax. It's extra cost for me because my design process is get this thing to be high performance, and I'm going to put a safety system on there that's going to rob performance, going to make the system more expensive, make it heavier, and so forth. Therefore, it's a tax. Yet, if you flip it around, it's like, how do I become safe from the get-go? So that I can be higher performance within my safety envelope, that I know
Hmm.
what the operational envelope is, and inside that envelope, I can run as hot as possible. But when I get to the edge, that's when my performance crimps. Then it's actually a revenue generator because you've provided a better product that creates less liability. It's a mind shift that needs to happen for people it's a design shift really that becomes with the mind shift that, okay, if I think about the design in the specific way, it becomes a revenue generator because it will differentiate me.
Yeah, product. Yeah. Yeah. So would you say that is the biggest difference, the safety layer between products that are demo ready versus products that are um, ready in a production environment to operate in real world?
Yeah. So when you think about like a production in a real world, you're talking about a task that's done thousands of times repeatedly
Mm,
over and over again for predictability, whether it's behavior, economic outcomes, and so forth. It needs to be extremely low for the high number of repetitions that you do. And if you have safety and behavior guardrails built in to make sure that variability stays low, then you have a production ready system where people will feel comfortable around. Demo systems, they look really good. They look really flashy. They create a good lunar year show,
yeah.
but it's a once and done thing. It's not, it can be repeated over and over again at scale to make money for people and to create value. And by the way, I'll talk about money and value interchangeably. But when I say money, I don't mean dollars. I mean the value that's created by some economic activity.
Yeah, that makes sense. And from a safety standpoint, perception also matters. So, have you seen a robot or a system that is technically safe, but the human perception feels that it is not it is not ready, and a person is not able to trust it? Trust and safety. Unpack that a little bit.
Right. We talked about autonomous cars. My car is autonomous. I love it.
As is mine. Yeah.
I can go for 4 hour drive and I hardly intervene. But there was a growth that happened with me with the car in the sense that at first I didn't feel comfortable with it until I realized that I was demanding that it drive like me
Yeah. Yeah. Yeah.
instead of me learning how it drove and becoming comfortable with it. So that's an example of a system that's very safe, safer than me. But until I
Mm,
get used to it, I don't trust it well enough. And to this day, when I get in the car and I put it in self-driving mode, passengers that haven't experienced that before, they get uncomfortable with it and they demand that I take over because they are used to seeing somebody's hands on the wheels, for example. So there's an anthropological artifact that needs to happen, which is we need to get used to these autonomous systems. And once we get used to them and we get used to their behavior, then they'll become invisible.
invisible, meaning it just becomes part of our fabric of modern life.
Yeah. I mean, like animals are pretty autonomous, but you don't notice a dog walking around or a bird flying. It's just like kind of nice. But, we see cars as dumb objects, but when the car drives itself, that's a novelty. And we stare and we point and we look and kind of stay away
Yeah.
until we become comfortable societally to those artifacts. They don't become invisible to us, that we just will not interact with them naturally.
I wonder if it's the next generation that grows up with autopilot, and for them it won't be novelty anymore, and they would not have to trust it because they just know that that's how things are. That's the fabric of reality, right?
Yeah, I mean, there could be a generational change. I can tell you that in the 40s and 50s and 60s, well, let's say, well, no, the time is wrong. In the 50s and 60s, we trusted nuclear energy more than we did in the 70s and 80s.
Yeah,
And
because that's a interesting one, because there was, from what I've read, we actually led a campaign to belittle nuclear energy, that it's not safe and we got to move away from it. There was lobbying against it, right?
there was lobbying
Yeah.
against it. And there was a 3 Mile Island accident that talking about a core meltdown that would go to the center of the earth, like a lot of nonsense.
Yeah, yeah.
It caught Hollywood's imagination and therefore caught everybody's imagination. Then,
Hmm.
thanks to Chernobyl, that lesson got reinforced.
Yeah. It just takes one terrible disaster to take out the technology. Yeah.
Right. But that's an example of, where the older generation trusted it, but the newer generation does not. And only now we're starting to see more trust for nuclear energy. So I can't guarantee that next generation will feel better about robots. Hopefully they will, because things are built safely and they behave predictably and they become invisible. But if there is a bad accident, or if a narrative takes off that these things are inherently unsafe, excuse me, if things are inherently unsafe, then the next generation will not be as supportive as we would like.
Yeah, that's an interesting distinction that you make. I wasn't thinking of the flip side of how the next generation can perceive the technology to be unsafe. I guess it depends on the traumas that you live through, right? And that's where it becomes paramount that we design systems that are not going to cause trauma and not going to make headlines beyond on the tabloids and beyond the clickbait stuff that is bound to come out. Okay, wonderful. I want to, this is great, Amir. Like I'm learning so much from just this conversation, and I think this is going to be valuable for our viewers that are listening in. So I want to pull a little bit from your experience. You've been in Silicon Valley. You've been around. Walk us a little bit through your background. We didn't start with that. How you got started, and what led you to Three Laws, sort of your journey and your founder experience.
Sure. I came to Valley, literally last century. So I've been here for a while. I came out as an engineer working on IT systems because that's what it was hot. And things were great. But then there was a dot-com bubble happening. And I had no idea why it was happening and what it meant. That induced me to go study economics and business to try to figure it
Wow.
on that side. And
Yeah.
that's why I went to study, got an MBA at Berkeley. And from there, I got acquainted with the startup ecosystem. I was a Mayfield Fellow at the time, worked for various startups. And post my MBA, I started working as a product manager for a company that was doing fast fabrics for inter-process connectivity, InfiniBand fabrics. That company got acquired by Cisco, and seeing the difference between a small company's speed and agility and
Yeah.
ability to pivot very quickly versus a large ship, which have to have a lot of process.
I've been at Cisco. I used to work at Cisco myself, so I know exactly what you're talking about.
Yeah.
Yeah.
Yeah. So from there, I decided to leave Cisco and then joined a small company at that time called VMware that was doing hardware and software. And that company took off, so I became a product manager for VMware ESXi, and you'll see it behind me here. That became a $1 billion product line that was fantastic. And that was kind of a big shift in a sense that moving away from hardware towards software, and things are happening at scale. But cloud computing became a thing at the time. And containerized workloads started replacing VMs at scale. So the architecture started to change. And with that came a host of problems. The host of problems were, one of them was cybersecurity. That, how do you at scale make sure that your access control lists cohere? And that was the core problem that my co-founders and I worked on. And we came with identity-based access control for containerized workloads. And that company got acquired by Cisco by Palo Alto Networks. And when I managed to work myself out of a job and go back to the startup world again, because machine learning was becoming a thing at the time. So using statistical techniques to learn about what you're doing. And I was at a company in founder capacity where we applied machine learning to right-sizing containers at operations and restarting them. So you have to right-size resource consumption. So therefore, your build-in turned out to be high. And that company got acquired by Cisco App Dynamics.
Wow. Cisco has been there for every turn of your career arc.
Yeah, Cisco has been kind of this constant. After that acquisition, machine learning, cloud computing, the things are coming in. The question was, where is the world going next? And two broad trends were very apparent. One was that across the globe, we're having demographic challenges like we've never seen before. When I was a kid, pardon me? Aging and shrinking populations. When I was a kid, I clearly remember when we hit 4 billion people on the planet, like there was this panic, like, oh my God, we're all going to starve. Here we are, 8 billion people, and our problem is obesity.
Yeah, that's very true.
Yeah, it's not starvation. And this is the first time in human history where populations are starting to shrink, not because of war or disease, but because of wealth. So if you have an aging population and your demographic tree shifts, it should look like a Christmas tree, split in between.
Yeah.
And now it's starting to look like an inverted pyramid or a column in many societies. That creates productivity problems.
Like for Korea, for Japan, not so much United States. We are pretty stable with 2.2 kids, right?
Because of immigration mostly. There are a few exceptions in sub-Saharan Africa where it's still expanding, but most of the world is either columnar, like where population has been changing, or inverted, where the population is dying. If part of the reason we live in as good times as we do, and despite all this doom and gloom, humanity has been never better off.
Yeah, it's true.
We've never been so wealthy. People kind of gripe about the disparity between rich and poor, and it's a real problem. However, the poorest of us lives a better life objectively than they did 10 years ago or 20 years ago. So if you want to make sure that progress happens, you have to have increased productivity. But that's one thing. Increased productivity typically came with expanding populations. Expanding populations has gone off. Now you have to multiply people's capacity to do more work. The second problem is the geopolitical tensions where factories are reshoring. COVID showed that supply chains can be very fragile. And now, there are tensions around the world where factories are coming back because you don't want the guys that are shooting at you to also manufacture your bullets. So it's like, so and if that's happening, so if you, let's say that your $2 an hour guy that's working somewhere else is being replaced by a guy that costs $20 an hour. Well, first you have a cost shock because your basis of production went up 10x. But in the US, we don't have enough of these $20 an hour guys to do the work. So you have to work your way out of it somehow, and autonomy and robotics became the answer. So the question became, how do you make absorption of autonomy easier? And I was lucky enough to find Andrew, Aaron, and Tom at Three Laws. Go on a journey with them for creating a safety layer that's universal that allows the absorption of autonomy much more easily. So crank up the autonomy layer, let it do whatever it needs to do. It can hallucinate. Yet if you have a deterministic layer that governs behavior and makes sure the system stays within boundaries, off you go. Then you solve the problem of human productivity through autonomous systems. You solve the factory problem, and you make it easier for people to trust autonomy.
Yeah. No, thank you for laying out that journey of early days and seeing all of the .com bust happening, your career arc from cybersecurity over to something as meaningful as Three Laws and so timely. That's wonderful. Yeah, please, yeah.
With every inflection,
Yeah.
new set of problems and those new set of problems are opportunities.
Mm.
Anybody who wants to be an entrepreneur, you may have a certain expertise, but the biggest expertise that you have is your brain. And you can think about the problem creatively. So the question is, as we're going through an inflection point, what are the set of problems that need to be solved? And with your skill set, how can you approach that problem that creates value for people?
Every disaster or every challenge creates opportunity, right? And so that's apparent now. And there's hope and optimism in everything that you're describing, that with all that doom and gloom in mind, a lot of the younger generation that goes, we are living through hell right now and things are so bad, as humanity have always been able to work things out and overcome the challenges using our technology, using our science, and we're able to come together. We just have to lean into what opportunities, what problems exist, and we're able to solve it when we put our minds together.
Precisely. And if you have a system that allows for creativity and reward, now I'm advocating for capitalism because it allows you to solve problems in a meaningful way instead of a centralized top down of, this is the problem we must solve today and all the minds on this, because the second approach is a lot more rigid and doesn't scale as well.
Yeah. And with that in mind, with that capitalistic hat on, if I'm an investor right now, and I give you a chunk of money, $50 million, let's say, and assume you're not at Three Laws, how would you deploy that capital? How would you use that? What would you build and what would you refuse to work on?
One of the things that we've talked about is for autonomy to take off, there needs to be a lot of trust in the system. So we need to see more of these robots around to make sure that trust happens. And how do you make these robots more prevalent is by creating more observability, more infrastructure, more controllability, more auditability. You want to prove to the adopters of the technology that they are able to see what's going on. They're able to control what's going on. They can go back in time and prove why certain events happen, good or bad. And that builds inherent trust. So with the $50 million investment I would get from you, and I will take it gladly, I would focus on these infrastructure tools that focus on observability, controllability, and auditability. I'd avoid these pure plays that are horizontally or rather vertically integrated. I would avoid building a humanoid company.
Got it. Why not humanoid? I know we've talked about all the different reasons why humanoid form may be more hype than anything. But is there anything beyond that? Let's say some of the challenges are worked out, the failure modes are no longer a concern, and there's a need in the market. Would you still not go for a humanoid, and why?
At first, there are a gazillion humanoid companies. Like every other week, a new one comes in. It's like it's a crowded space. It's hard to differentiate yourself. They all kind of do the same thing.
But my $50 million will come because you're launching a humanoid company. An excitable investor, just like any other investor in the valley.
But I'm not in the business of taking your $50 million. I'm in the business of returning 500
Yeah,
million to you.
yeah, yeah,
So
yeah, yeah.
if you're going to make a bet on me with $50 million, then I have to deploy it in a way that I can have a higher chance of returning 10x that money
Yeah,
to you.
love it.
Yeah.
That's a great answer. Yeah. And on that note, do you think, in looking at your past experiences and all of the things that you've built, have you ever felt like the market wasn't ready, but you still went ahead and built something?
To some degree, three laws is an example of that. I talked about the three chunks of markets, the experienced innovators and then the old school.
Hmm.
Old school says things are, it's like they're like that dog in a burning house. It's like everything's fine.
Yeah. Yeah.
Yeah. Yeah. So that's a chunk of the market that's currently unreachable for three laws. We try to break our pick on these innovators and say, hey, look, we can make your humanoid better. But they are focused on the wrong set of problems for us. They're focusing on something that razzles and dazzles. For them, it's a right challenge, let's say. But for their challenge and our value proposition doesn't match. So by pairing our technologies with companies who are experienced and who know these problems, and that's a tiny portion of the market, but that's exactly when you want to come into market, when it's slightly too early, but you can see what the movement is. Then you can have a good landing pad and expand from there.
Yeah. And looking at that bigger market of robotics and everything that's taking place, do you think companies are just over concentrating on autonomy piece? Is that more than the focus needs to be on autonomy?
Could you repeat the question?
Yeah. Are companies over focusing on autonomy right now, you think?
I don't think so. No, I think autonomy is a way to create multiples. And let's use autonomy and AI interchangeably right now. Um, they the purpose of autonomy and AI is to create scalable workforces.
Yeah.
With the same workforce, you get X done. And the companies that crack that first will be far ahead of the game. And just to let you know about an experiment I did recently, like OpenClaw came out, I deployed it.
Yeah.
At first, I deployed it on my local machine, a bad mistake because it took over and started communicating with everybody on WhatsApp on behalf of me. And
Wow.
yeah,
Okay.
and
Yeah.
that was a little scary. So I built VMs and I deployed them in the cloud. And they have I have three different VMs and three different personalities with three different backends, and they have specific roles. One's a product manager, one is a designer, one is a developer.
Okay.
And so I talked with them through Telegram. And as an experiment on a 1 hour flight, I got and said, look, design a game that hasn't been created before, checking the code to GitHub, right? I'm telling the different personalities,
Yeah.
right? The instructions and the product management documentation for it and give it to the designer. And designer, you're responsible for come up with a script that looks like a movie trailer to make this game exciting. And then I turned the phone off and landed about an hour and 10 minutes later. There was a game that they created called Cyber. And so that's an example of work that can be done at scale. So I think if anything, companies are under appreciating how meaningful autonomy can be. You can do a whole lot of work really fast at quality if you
Hmm.
absorb autonomy and AI appropriately. I don't think companies are over leaning on it. I think
Yeah. That's
most people don't.
that piece. I wasn't even thinking of how work gets done at enterprise level with OpenClaw and other autonomous technologies like that. Yeah, that's a great example. Speaking of that, what's your viewpoint? We're slowly going to scale. Are mass layoffs coming because of that? People that are not going to be giving on that management layer, laying out the vision for a product. I feel those product managers and executives, general managers, that leadership layer is potentially safe, but the actual doers of the work, are they out of here and they're going to be replaced by different agents?
The answer is I don't know. But one answer is there will be displacement. I don't think there'll be unemployment. And so let me give you two inflection points in my life. I figure I'm pretty old now. I'm old enough that when I was growing up in Iran, consumer calculators became a thing. And I remember holding it in my hand. I was playing with it. And my father told me, do not use this. You won't be able to do math correctly. He was confusing thinking with arithmetic. When you add and multiply numbers, you're just going through an algorithm, through
Yeah.
rote as an algorithm. And now my kids use much better calculators, and they're better at math at that age than I was, because they've learned how to think better. Now, that's kind of phase one. I remember in the 80s, I started seeing spreadsheets coming around, and the prediction was, oh, these spreadsheets are going to put all accountants out of business.
Business. Yeah.
They're more accountants than ever before, and they're a lot more productive than they were before. So fast forward to all these tools. What will happen? The answer is we don't know what the shift will look like. But if you get away from the rote, from the algorithm, and figure out how to apply your brain and use these tools to apply your brain more creatively, there is room for you and you'll grow. And it's not like the size of the economy is a fixed size pie. The way capitalism works is there's wealth generation. It's not taking wealth from one pot, putting another. You just generate wealth. You have GDP that grows. So each person can produce more. Done correctly, actually, I think employment will increase. There'll always be a shortage of people that will do certain creative things, and tools will keep scaling up. There's some people who depend on rote, and they will suffer because systems will do their work over. If you're doing a repetitive task and you think you're doing a great
Right.
job, that those systems will eat your job away.
Yeah. No, very eloquently put. That any new technology, there's fear there, but if you view it from a perspective that it's a tool to be utilized by a human, and your core skill is strategic thinking, creative thought process, creation, then there's nothing to fear, because they're just guys, just a tool, just like a calculator. Nicely put. And the other piece, I like what you said, that it's not capitalism. Oftentimes politicians make it seem like it's a zero-sum game. The cake is not limited. Oftentimes politicians are pitting people against each other, that look, there's only one slice and that side is going to eat your slice. But that is not reality. Yeah.
Yeah, it's you generate wealth, you don't steal wealth.
hmm I know we're approaching time with you, and I'm mindful of that. Let me ask you, going back to robotics, is there one belief about robotics that you have changed your mind on in the last 2 years, which have been pivotal years?
Yeah, unfortunately, I think the adoption of robotics is going to be slower than I had predicted 2 years ago.
Really?
Yeah.
Because of safety, trust, all of these issues?
No, because I was wrong. When you first get into it and you're a giddy entrepreneur, you believe that, vast wholesale change is going to come in half a decade.
Yeah.
It always takes 10 times as long. But what I believed was wrong. The world is as it is.
Elaborate on that a little bit more.
Yeah. So, let's say that, how long will it take before our cars are electric?
Mm,
That won't happen, right? It has significant benefits, but that's a good case study. That first you have to have the infrastructure to mine the batteries, to build them at scale, to get them cheaply. You don't have any kind of rare earth problems that come with it. You have to have the scalable manufacturing capabilities. Prices that initially were like around $100,000 have to come out to, like, let's say between 35 and 25,000, which we're now seeing. You have to be able to charge your car very rapidly. People are used to going to the gas station and pick up gas. Therefore, how are you going to fuel up cars rapidly so people aren't burning an hour to 2 hours with these fast chargers? Those are fast chargers, take 2 hours, 1 to 2 hours. And then if you have enough of those, let's say now you can charge your car in 5 minutes, which most people would say, give me 2 minutes or less, because that's the scale of my patience. What kind of grid do you need to support that? And now you build the grid. Okay, where are the power sources coming from? Where it shouldn't increase carbon pollution and it shouldn't destroy the environment. Like, in order to get to one goal, there are all these cascading goals that go out.
yeah.
In order to make that reality viable. Now, with robots, it's similar. It's like you need to have the supply chain in place. You need to have the safety layer in place. You need to have the regulation in place. You need to have the mindset to change for people to say that now I trust these things. As a giddy entrepreneur, I would say, oh yeah, 5 years. But like, okay, it's going to take a generation and a half before everything changes and lines up.
Yeah. That's a great insights. And the other piece is also there are other industries and other interests putting up oppositions against what you're trying to do. Just like with nuclear technology, that example that you were talking about, there's people's jobs at stake potentially, or at least perception of that. So there's regulatory, or from a legal standpoint, oppositions that people are putting in place that we don't want automation. We don't want this development. So that also slows the progress or development down. Yeah. Okay. And then let me ask you this one final big chunky question. If a founder is listening, what advice would you have for them? What mistakes to avoid focusing on robotics and what things to consider?
So is this founder in robotics or in any business?
Robotics.
Robotics. First is appreciate that things will take a long time.
Mm-hmm.
Having said this, have a mindset of trying to be as fast as possible. And the best way to know if you're fast is the signal to listen to is the dollars coming in from customers. If customers are willing to pay recurring fees for whatever you've created, then that's a signal for you that you're creating value for them. And if that's not coming in fast enough, then you're not being fast enough in adapting to the market and adopting your processes internally to make sure that the right set of changes are happening. So listen to the customer carefully. Don't listen to what they say, understand what they mean.
What they're willing to pay for, the cost of acquiring the customer, make sure that's lower than the lifetime value of the customer. The math has to work out and yeah.
Right. But one of the arts as a product manager is like, somebody says my problem is X and my problem is Y. What they really mean is like, I want a process change. I don't want feature changes, for example. So understanding the problem more deeply and figuring out how to address what they want, because oftentimes people will communicate in a way that's obvious to them, but they haven't thought about their problems deeply enough because they don't have time for it.
Or they say something, but actually mean something else.
Yeah. But the Henry Ford aphorism is like, I ask people what they want. They say they want faster horses. So if you're used to thinking in terms of horses, then the idea of a car is very alien to you until you get a car. Then you understand what it does. So as an entrepreneur, you need to really understand what is it that they want to do. Here, they want faster horses because they want to get from point A to point B faster. So how do I get them from point A to point B faster? Screw the horse. There's something else that can get the job done. That's what the founder really needs to listen to. Listen to what the problem is, how to solve it creatively, rapidly, and make sure that you're getting the right signal from the market that what you've done creates value. And that is through recurring revenues.
Yeah, wonderful advice. Nicely put. Yeah, humans are so complicated. That's why we need more robots. We can just deal directly with robots and they will tell you precisely what they want and what's going on. The analysis would be correct. I'm joking, of course. Wonderful, Amir. Before I let you go, there's a tradition that I've established that we jump into lightning round as we let you go. I'm going to throw a whole bunch of questions at you really, really fast and get your first reaction. How does that sound?
Perfect. Let's go.
Okay. Best thing about Silicon Valley?
Silicon Valley is a new Florence. It's where Renaissance is happening. Our art is a new technology. This is where the best of the world is coming in to create the future. This is the best.
Beautiful answer. What's our Uffizi gallery?
I guess the Computer History Museum? I don't know.
I haven't been there. It's been on my list, but I haven't made I've charged there on, they have a Tesla supercharger in the same parking lot. Yeah. I got to check it out. Best thing about your job?
It's an intersection of hardware, software, real world impacts, and people issues that all need to be solved together. It's a privilege and opportunity to put all these pieces together to create value for the end customer.
Love it. What's the most challenging piece of that?
The gap between what is technically possible and what is stress tested and perceived to be safe.
Makes sense. What's the most exciting development happening right now in robotics that is not hype?
I think robotic capabilities and autonomy is scaling pretty fast, but control and deterministic behavior is not scaling as quickly.
Would you say that is the most alarming thing about state of robotics?
I would think so. Predictable behavior. And the reason I would say alarming is it's not that robotics are going to get unsafe. You want the robots to be adopted quickly and you want the economy to grow quickly. Then you want to have the scalability of predictable behavior so you build trust so adoption happens faster. What
feature about a robot signals that the robot is safety ready?
It's the ability to be context aware and within that context make the appropriate adjustments in real time.
One thing in your life that you want robot to help you with today?
Oh goodness, I have a large family. I have 6 kids, and those 6 kids create a lot of entropy. Like things wear out, things break, and Each one of them is an structure to the problem. So it would be nice to have that robot take care of their mess and fixing.
Do you want a nanny or do you want a handyman?
I want both. No, I don't want a nanny. I want a handyman. I want one the sanitary robot, the cleaning robot, the handyman robot, the gardener robot, all wrapped in one.
You've already admitted that there's no escaping entropy. Entropy is going to happen. Kids are going to break things. You're not stopping that. You're saying, let me
fix it scalably,
Yeah.
and so I can focus on the kids instead of their mess.
Yeah. One thing humans do better than robots, hands down.
It's generalization in unstructured environment. I'm going to bet that if I take you and I'm going to drop you in the corner of the United States, where you within 5 miles you can get to people, within a couple of days you'll be able to get back to your home in the Bay Area. Now think about the amount of processing that took and the problem solving. That's hands down, people are better at that.
It's millions years of iterative product development, right?
Right. Now you can drop a robot somewhere randomly and then GPS location can figure out where it is. But then good luck having that robot problem solve its way so it's back home.
Great way to explain that. On that note, last question for you. Now go to 2050 in a time machine. You come back. What message do you bring? What have you seen? What does the future hold?
It's a really good world. It's one where kids are safe, food is good, environment is clean. You don't have to own cars. And basically, there's a lot of autonomy taking care of the minutia. And you're focusing on building skills and building meaningful relationships. You're not glued to your phone. And the robots are taking care of all that stuff. You're doing the good stuff that you need to be doing in order to have a better life.
Man, you've painted a utopia. Love your optimism, love your energy, love your knowledge, wisdom. It's been wonderful talking to you, learning from you. And I think this will be very valuable for people within robotics or anybody that's trying to unpack what's happening in this crazy world that's out there full of entropy with lots of things breaking and a lot of things not working and human beings not able to come together. But you're ending with a positive message that we will figure it out. Everything will be fine. We've done it in past and we've gotten progressively better and the human arc is headed in the right direction.
Ali, thank you so much for hosting me. It was a pleasure.
Yeah. Thank you for staying later. It's been awesome. Thank you, sir.
All right. Until next time. See you around.
Yeah. Talk to you soon.
Bye.
Bye.